Okay, so also I've already put these slides up on SlideShare, so if you can't see them for some reason, they're up there right now. And we also have a videographer who I think was sponsored by TypeSafe, so at some point you'll be able to search the web and find this video. And let's see, I think that's all we need to put here. Shameless plug. This is the my most recent book, Atomic Scala, and you can get the first 25% in the just as a free download, and that's in Kindle, EPUB, PDF, and HTML. And I spent a lot of time figuring out how Kindle and EPUB worked and how to make it work with code listings, and we had narrow code listings so you could actually hold it on your Kindle handheld device. It took a lot of effort to make it work right. TypeSafe also has the first 50% as a PDF. So the other project that I've been working on for the last number of years, this is a picture of Mount Everest because I came across a book that said everybody should have their own personal Everest to climb. My own personal Everest, it turned out, was that the reason that I became a consultant is that I didn't want to work inside of a company because I had decided when I was in my teens that they were all horrible to work at, and so I didn't want to have anything to do with them. And then I got to this age and realized that maybe they wouldn't have to be. So what I'm trying to do is figure out how do we make companies that are fun enough that even I would want to work with them. And this has led me to a lot of interesting places, including recently somebody turned me on to this book, Start With Why, and there's actually a TED Talk, which is probably enough for you. The book goes more into why businesses. One thing I wanted to say is there are seats around, so if you guys, there's like a bunch of them here, so if you guys don't want to stand, which it's going to get boring, come up and grab seats. The TED Talk is probably enough for you to get the idea. And there's also a podcast that helps people figure out, what your why is. So I hope this will make sense. Why I'm going to start explaining this. It turns out that, well, anyway, let's. Oh, wait a minute. I have to back up a little. So his premise is that most companies and individuals focus on what they're doing. So people might say, oh, I'm a writer. Well, a writer is what? You put words on paper. That's what it is that you're doing, or that's how you're expressing yourself. Maybe I'm a writer of science fiction or travel or something like that. The what is the science fiction and the travel. The writing is how. But why you're doing something isn't really expressed there. And so the problem is it's really easy to lose track of why you're doing things and kind of drift off into the weeds, which I kind of felt like I had done. And so I have been studying this and trying to figure out what my why is. And so I initially came up with this idea that what I was trying to do is break the chains around our brains. That is nice, it rhymed. It fit with everything that I was doing. I was going, okay, the reason that I work with some of these programming languages is because the more primitive languages are holding us back, and people get stuck into those, and then so they get chains around their brains, and so I'm helping break those. And the problem with that is that this is a how. That's how I'm doing. Well, I don't know. What is it that I'm trying to achieve? Unstick something, maybe, but that's unstick what, and why am I trying to unstick things? Maybe what I'm really trying to do is find the alternatives that are going to happen if you unstick wherever you're stuck on. Little closer, maybe trying to burst forward. I'm trying to make us more productive, perhaps. So these are all happening like several days at a time. I'll get an idea and I'll go, yeah, that's it. And then I'll think about it for a few days and then think, no, that's not really a why, that's a what, or that's a how. So now I actually made a painting about leverage a couple of years ago to use in presentations. So I think, oh, the fact that I did that, maybe leverage has a lot to do with it. I'm trying to help people gain greater leverage to try and move the world. I still don't know for sure. But that's the path I'm going down. I'm trying to figure these things out. And the reason that I said that is at the conference in Budapest that I was at a couple of weeks ago, I created a presentation for them which was quite adequate. It was called What Makes a Good Development Process. And as I was giving the presentation, this guy I met and spent a bunch of time there with Dan North, some of you may have encountered him. He gave a presentation right before mine, and it was really, he was really connected and heartfelt, and you know, I could see, oh, that's what it means to be connected with the material that you're giving. So then I got up and gave mine, and I don't know, I didn't really care about it. I had created the material because I thought it fit the conference. I was doing it for the conference and not because it came from the heart. So I think the presentation I'm about to give you is the one that I should have given to them. And I would probably have titled it, Do Languages Matter? And the answer is, of course, they matter. I've spent a lot of my time, years of my life. I was on the C++ Standards Committee for 8 years. I've been writing books about languages. Oh, yeah, of course they matter. Maybe the question is, do they still matter as much? Or to put it in terms of action, does arguing about languages still matter? Yeah, I know that sounds funny, but really, that's essentially a lot of what I've done is tried to, I mean, I don't really like full-pitched arguments, but essentially what I've tried to do is argue for better things in software development. And I think what this comes down to is, at the beginning, arguing about languages was worth the effort. And then we've slowly gotten to the point where maybe we're not gaining as much. And if what I want is big leverage, that suggests that if I'm in this area, that I've gotten into the wrong arena. So back when I started, there was a lot of people still doing assembly language, and this idea of moving to this C language was kind of ridiculous because of all the inefficiencies that the compiler would produce over assembly. Seriously, people argued this way, and processors were slower, so you could make a case for it, but the productivity increased by moving to C, so you didn't have to do all of that stuff by hand every time, was huge. And so, yes, that was certainly worth arguing for. When we moved from C to C++, one of the things that happened here was it forced the existing C to be more standardized because pre-ANSI C was kind of hacky, and it was really designed to be a portable assembly language. And so when C++ was coming along, that forced some features into C. The ANSI process hadn't happened at that time, and some features went from C++ to C and improved the language, and anyway, made it a lot better. But then with C++, we're able to think about much higher level data structures. And so again, we're still on this part of the curve. And Java comes along, and yes, Java had a lot of questionable decisions, but some of the things that it brought along were the idea of virtual machines and garbage collection, which, when Java first appeared, were still ridiculous concepts. That could never be efficient enough. And you can see the pattern of argument. It's like, oh, well, it'll never be efficient enough. And of course, now we've had enough time to not really think about the efficiency of virtual machines and garbage collection. It's basically proven. We've had faster and faster hardware, and we realized, yeah, our time is much better spent in using a high-level language than it is chasing some of the bugs that happened without this kind of stuff. All right, so yeah, this is all still good. Then at some point we started having an argument, and it depends on how much you've followed my work over the time, but you'll realize that, yeah, I started some of these arguments, or I was at the beginning of some of these arguments. I don't know if I started, I probably picked up on them and amplified them or whatever. But so here we have this statically typed versus dynamically typed languages. And initially, it was just like, oh, well, yeah, there's no way that you can possibly create a serious project using a dynamic language. But time has passed, and people have created big, complex projects using things like Python and Ruby and other dynamic languages. And so it's harder and harder to argue that. But initially, it was just so obvious that, oh, well, you could never use these things for serious work. And this is an interesting change, because I think we're kind of moving towards that part of it. And by that, I mean because instead of arguing about it, we actually just do the experiment. And then another argument that I seem to get involved with early, I suggested that maybe checked exceptions weren't the best invention in the world. And oh man, there was a lot of furor over that one. Yeah, I really wasn't trolling, but it seemed that way. I was trying to make reasoned arguments. And then we get to things like concurrency and parallelism. And the argument that I made in that case was that you could have locks and threads at the very small level, like the operating system level, where you have to be very, very careful to get it right, or you're going to blow something up. But for whole systems, locks and threads are basically impossible to get right. And when I first started suggesting this, I always had people who would come up and say, well, you can't get it right, but I can do it. You know, and I'm thinking, I don't ever want to work on a project with you. And most of the languages that we're seeing being developed now, like Go and Rust and a number of languages like that, are moving more and more towards CSP, communicating sequential processes, because that's the easiest model. It's the one that you can teach, like if you were teaching a seminar in Go, at the end of the week you could be teaching, well, actually all through, you could be teaching, okay, here's how to do concurrency. And people would be able to pick it up, and they wouldn't have to struggle with the kinds of things that we had to with Java, with locks and threads, which was an advanced topic that only very special people were able to deal with. So we're moving, and then of course now we have the OO versus functional, revisiting that. And I don't know, I think this is a situation where we're just learning by actually trying things out. And one of the things that came up, the Java Posse Roundup, we just had our 8th conference. We've been holding it for 8 years. And we realized that for like the last 3 years, nobody's really been talking about Java. So the Java Posse is kind of like closing their doors, and we're going to change the name of the roundup to something more appropriate. Because we realized, oh, we're just not talking about Java anymore. So that's kind of another clue. In the end, it's not really a big deal to change languages. Like, for example, I had a consulting client which they had been using Java and having a lot of struggle with it, and but they couldn't imagine changing because they had all this investment or whatever. And so I came in and showed them how, because it was more appropriate for them, how they could be much more productive in Python. But I had to prove it by being there. And they said, well, we have this thing. We think it'll take a couple of months, and I might be able to write it in a couple of days instead. And after a while, they started looking at this going, yeah, this looks like more fun. Now, the last time I talked to them, they had spontaneously decided to change again to Go, which is for them a more appropriate choice. But they didn't need any help doing that. They had figured it out. And I think a lot of people are more comfortable changing languages, whereas before it used to be this big deal. Oh no, changing the language would be a fundamental shift in the whole meaning of the company. The other thing is combining languages. I ran into an Erlang person at the conference, and he was talking about how easy it is for Erlang to interface with other languages. I haven't done this, but I want to experiment with it. We're also very used to REST APIs. We're used to talking to other systems now, so it's a lot more comfortable with us. And for UIs, this is becoming the global standard for UIs. So we're really getting more and more comfortable with using multiple languages and multiple systems and having them communicate with each other. So I think for me, what I've done for a good portion of my professional life, which is argue to consider new languages, that no longer really fits my why, because I don't think we're stuck there anymore, and I don't think that is the biggest leverage that we can get, because now people can just experiment, and that's what they do. They try things out, and they go, oh yeah, this works for me, and it doesn't. You don't really have to argue about it. The reason that I'm telling you all of this is to give you some context. In particular, I'm not attacking your favorite language. I'm just asking whether we can make development a lot better, because that's what I do. I mean, I don't know exactly what I do. I don't completely know my why yet, but I do know consistently that's what I've always done. How can we do this more? How can we get greater leverage? That's, yeah. So I kind of look at things and I jiggle them to see is maybe there's some better way to do this. Bill says that I hang out with early adopters, and that affects my perspective. That's probably true. But anyway, so my main question that I want to ask is that, yes, people do seem to be much more productive in Scala versus Java. I can see all the reasons for that. But is that the best paradigm, or are we falling into yet another hole? Is there some other way to get more productivity? And most of these are just questions that I'm asking. I don't necessarily have answers to this. And I know there's been a lot of furor. There's some people who have left TypeSafe and have talked about it, and the Scala news groups and everything always have people who are complaining about this or that. And that's not really what I'm talking about here. But to me, to justify changing from one language to another, you need to have some multiplication of productivity. It can't just be, yeah, this is 50% better, 20% better, whatever. I think to justify the effort, you have to be able to multiply the productivity over the alternatives. And Scala does that. Yeah, it does. And one of the cool things is that it maintains two-way transparency with Java. And so that gives you a lot of leverage from both ends. You can use existing Java libraries, and if you want to create something amazing with Scala and call it from Java or provide it to Java programmers, all that works really well. And this is a big one, not gridlocked by backwards compatibility with Java. Java, I think, immediately made a big mistake that other languages have tried not to duplicate, which is to say, regardless of what errors we've made in the language design and the library design, they're cast in stone and can't change. And so that has, I think, really held it back, and that's caused a lot of productivity problems. But I do have an interesting question, I think, without the constraint that, well, we want to be compatible with Java, we want to work on the JVM, all those things. Is Scala still the best choice? And I'm just wondering about that. One of the things that I certainly encountered when wading into the Scala world is community. And I've had a lot of experience with, I've spent a lot of time with Python and their community, and I would say that it may be the most friendly and welcoming of all communities that I am aware of. For example, despite the kerfuffle that happened at the Python conference a couple of years ago, there's about 20% women, which is higher than at least any conference that I'm aware of. And they're not just showing up and being passive. They're actively involved. They're doing things. They're making the conference happen. They're having groups within the conference. So I think that's an important indicator of how friendly that community is. Scala, on the other hand, those of you who know what League of Legends is, have ever played the game, I only know about it because my friend Barry was a director there for a while, and now he is moved to the company that makes World of Warcraft, which has, despite their name, a much friendlier environment. So League of Legends has this reputation of being the meanest game in the game world. In other words, people in that community are really mean to each other. And the Riot knows about this, and it's done some fascinating experiments to get people to be nicer to each other. Things that anthropologists and sociologists would love to be involved in, because at any time you've got maybe 300 or 400,000 people online, and you can flip a bit and see behavior changes among them. And that's the kind of things that they've been doing. Really, one switch they flipped, and it just changed the default setting, and suddenly people were behaving nicer to each other. It's kind of mind-blowing stuff. Well, anyway, for whatever reason, this behavior is the same kind of thing that we seem to have in the Scala community. People are just mean. And I've been around the computer world long enough to go, oh yeah, that happens, who cares? But so when I had to start asking questions for the book, I accidentally stumbled into some quagmire of nasty people, and they started saying mean things, and I just went to another news group and asked questions. I don't know how many times, changed once or twice. Pretty soon I found a news group that was friendly enough, and they answered my questions and things. But in Python, Guido has always had this thing that he says is, be gentle on the internet. The person who's asking the question might be only 14. And he's always tried to create that culture. And I think that's super important. And we have not had that. And culture starts kind of at the very beginning. So it's something that hopefully it's not so far out of control now that it can't be reined in. And I heard about this secondhand. Apparently there was some kind of rage over the title of Atomic Scala. There were people who were going, well, if it has the word atomic in it, it should be about, locks and threads and concurrency and stuff. And you're not supposed to use. So for those of you who don't know, the reason for the book title was that this is the first time that I've tried to create a book that was actually that could be used for beginners. I understand, I've had a lot of people tell me that both Thinking in Java and Thinking in C++, and I've written books before that, but these are the first ones that I'd say I had kind of gotten the knack of writing books. Lots of people said, oh yeah, that was the book I learned from. And I said, well, that wasn't the intent. The intent was for professional programmers. So Diane and I wanted to make this book something that could be used for both beginners and professional programmers. And so we did a lot of stuff for that. But one of the things that we tried to do was, because of my own experience reading books, I discovered that I get this little endorphin bump every time I reach the end of a chapter. It feels like an accomplishment somehow. So the idea is, well, you make the chapters really small, and you get that a lot. You get that sense of accomplishment a lot. I know it sounds silly, but it really, I think it makes a big difference, especially when you're dealing with people who are just learning to program and a language as complex as Scala. So the idea was to break the chapters down so they were so small that they couldn't be further divided, thus the name Atom. From the original Greek. And so the chapters are only like a few pages long. Anyway, that's where that came from. One of the things that came up at this conference in Budapest was, Dan North said, he put it in an interesting way. He said, Scala is the most unopinionated language that I've ever seen. And by that he meant that there's like tons of different ways to do things. And another speaker said, you can do things in so many different ways that each team or company has to develop its own culture, which means that the code that you're going to look at is going to look different depending on from one culture to another. And because language is about communication, subcultures produce cognitive load. It just means that when you're reading somebody else's code, you have to spend a fair amount of time unraveling it and figuring out what it is that they meant. And that, well, so there's a price. Let's just say there's a price to be paid for that. And on the other hand, look at the Go language. Even with that, they have decided what standard code formatting looks like. To eliminate the whole code formatting arguments. They go, we will have, as part of the delivery, as part of the package, there will be this program called Go format, GoFumt. And it will format your Go code in the standard way. And that way, when you're looking at Go code, you don't know if it's yours or somebody else's. It all looks the same. That's a good thing. So yeah, so anyway, I mean, I think the Scala experiment is great. It's just, it has these issues, like the jump in complexity. Well, When we were working on C++, the original term, actually the original name for C++ was C with classes. So the idea was just to add object-oriented classes on top of C, and then a bunch of other things got added on top of it, and that became inappropriate. But one of the benefits of C with classes is that you could go, and this is the reason, a lot of people say, oh, the reason for the complexity of C++ was because the people who designed it were stupid and didn't know what they were doing. No, I spent a lot of time with those people. And they're totally not, I mean, they were really smart. The problem was that the constraint was that you had to be able to program in C inside of C++. And that added all kinds of difficult complexities, which caused misunderstanding for decades after, including Gosling's decision to say, well, operator overloading is complicated and difficult. It's complicated and difficult in C++, yes, because it had to be backwards compatible with C. But as we've seen in Scala and Python and Ruby and lots of other languages, operator overloading doesn't have to be that way. If you got a garbage collector, it makes it quite easy. Anyway, but that was one of those decisions that because it looked complicated in C++, Gosling and the team decided, oh, well, it's too complicated to put in Java. The thing is, Scala isn't Java with anything. It's really different from Java. So you don't necessarily, with C++, the intent was to draw C programmers into a larger world. With Scala, the familiarity is that basically it's running on the virtual machine and you can talk to Java, but the language is pretty different, and so it's a big jump in complexity. So there isn't really an advantage in knowing Java if you're moving to Scala. And so there's an interesting question. Do we even care about Java programmers, or are we only doing this to work with existing Java libraries and the ubiquity of the JVM? And I think this is a legitimate question, because if we're not, one of the things that we encountered was that virtually every Java book out there with, no, I think even yours is the same case. Sorry, every Scala book out there said, OK, so here's how you do it in Java, and here's how we do it in Scala. So they all assume that you have this understanding of Java, which we didn't want to do. We wanted to be able to take somebody from being a non-programmer to a programmer, a dedicated person, not, this isn't 24 hours or made simple or anything like that. But I think this is a legitimate question. Are we really trying to bring people from Java to Scala, or from other languages to Scala, or what is the point? Even though all of the books out there do assume Java knowledge. And the bottom line is, what is the why of Scala? What is its primary motivation? There was this fellow at this conference in Budapest who was, he was telling me he's a Scala programmer, but he really likes Clojure, and he made an interesting observation, which is that he liked using Clojure libraries rather than Scala frameworks, or frameworks in general, I think is what he said. And so it occurred to me that, yeah, libraries always seem easier to use than frameworks. It seems like libraries have like one dimension of complexity, and frameworks seem like they might have 2 or 3 dimensions. My perception is that it's always been harder to get used to a framework. And you have to kind of figure out, one of the difficulties about a framework is you don't know ahead of time, are you going to run into a wall? What's the benefit versus the cost of complexity? And once I get comfortable with the framework, how hard is it to change? So I don't know. It's an interesting, I'm just trying to make an observation here to generate discussion. There are also these other language options. In other words, we got Scala over here. Is that the best choice? Should we look at maybe some of these other languages? One of the examples I want to try is the thing that I recently learned about, is start with an Erlang controller, which does concurrency and parallelism very well, and use operations coded in Python and other languages, and just kind of see how quickly the speaker was making an argument for being able to very quickly put together very robust systems that way. I want to try that. And then the Rust language, I was at Mozilla talking to them in the last few months, and ended up spending a lot of time discussing Rust. And then Dick Wall and I, at the end of the Java Posse Roundup, we spent half a day exploring Rust. And I thought Rust was like some clone of Go, but actually it's quite different. It draws a lot of features from other languages. Their argument is that they only use proven features, and but things like they have pattern matching that looks very similar to what Scala does. It's not a limited pattern matching. It's quite powerful. It's native compilation, has a garbage collector. The goal of Rust is to create a language to create the next version of the browser in, so that it can be really fast and robust and everything. And so they're starting with the language. But I think it's helpful to have a goal like that when you're creating a language, because it kind of keeps you practical. And anyway, I think there's a lot of possibilities with Rust, and I want to explore it further. So we had our first Scala summit in Crested Butte. This is the mountain in the summertime. It's quite beautiful. And you can go to scalasummit.com to see when the next one is. The next one, because of Bill, who's always saying, oh, can't we do things when the leaves might change? It's hard to know exactly when the leaves are going to change in Crested Butte, but I said, okay, well, we'll move it a little forward. So it's in September. The leaves might be changing. You can never really tell, but the weather is fantastic so this is at 9,000 feet in the Rockies. Anyway, in the first Scala Summit, a couple of the things that came up, James Ward and I had been trying to figure out monads for, I don't know, a year. And those of you who've tried to do this know how it works. You find an article or a video or something where the guy says, nobody else can explain monads, but I can. And then they go on to try and explain them, and you go, I still don't get it. In fact, at this conference, I was talking to Dan North, and he says, I have the perfect explanation for monads. It involves school buses and old ladies. and I said, okay, I want to hear this. And then for some reason, the subject never came up again. And so I still wonder, how is he going to explain that? So anyway, I don't remember who said this. I think it was one of the TypeSafe guys. And they said, you don't actually need to understand monads. You can just use the language. And because all this time I was thinking, got to understand monads or else I won't be able to use it properly. But no, apparently you don't. And the other thing, the point that came up, which was kind of mind-blowing, was this idea that Scala is taking functional and OO, which are two really different paradigms, and kind of mashing them together. And initially, I was looking at this going, yeah, sure, they fit together somehow. But they actually don't fit together very well. It's a collision. And there's some sharp corners here and there. And it was just really useful to have somebody say that, because you step back and you go, oh, yes, this is why this thing doesn't fit here, and this is why this doesn't fit here. And so why sometimes you can have the OO stuff and the functional stuff kind of work together, but a lot of the times you have to kind of treat them as separate creatures, because they don't really work well together. And it helped clarify a lot of things. So those were two things that came up. So these conferences that I hold are called open spaces conferences, which means that they're not predefined. We get together and we have discussions. We don't have speakers. And so a lot of really interesting things come up with them. And then we go outside and hike, or ride mountain bikes, or do outdoor things. And it turns out that a lot of really interesting discussions happen during those too. So anyway, last thing I wanted to point out was, this is just hearsay. Of course, it might have been from Bill. I don't know. Anyway, so Scala 3 is coming along, and it might make some significant non-backwards compatible changes to the language, which would probably be put there to fix some important issues. It could alienate some users. As Bill observed, I hang out with early adopters. I've always been somebody to push for changes rather than to stick with the old stuff. So my inclination is, and I heard this, actually this came from Strustrup, working on the C++ committee. He said, we think that if we make this change now, it's gonna, there's a lot of people complaining about it, but he says right now we have only a small fraction of the users, and if we don't make this change, we're basically hurting the much larger portion of users that will adopt the language in the future. And so I think it really is important to perhaps this is one of the better things that can happen, and it might fix a bunch of those issues that I'm talking about here. So restating my question, could a different paradigm give us a lot more productivity, or are we sticking ourselves in yet another box that we're going to be angry about? And that's all I wanted to say. But if you have questions or comments, and you're not too hot from being packed into a room, we can do that. Okay. All right. Okay. Oh, yes.
Do you have any thoughts? I was intrigued by your community's observation. Do you have any thoughts about what engenders a particular style of community? In other words, is there something intrinsic to a language itself that influences the community, or is it just some randomness, or do you have any thoughts there?
Can you repeat the question?
Yes, repeat the question. Yeah, okay. No, I mean, I'm sorry. I didn't mean you repeat the question, me repeat the question. Okay, so wow. So this was really a question about sociology. Does the language influence the community? Does the community influence the language? Are they completely separate? I guess, well, this is slightly, okay, I guess the experience that I've had, that's an amazing question. Because my two deepest experiences have been with C++. I guess I've spent a lot of time with the language designers of both C++ and Python. I don't really know if Gosling knows that I exist or not. So I really never spend any time with him, and I don't know. So my exposure is to the people who kind of lead and create the languages. And but see, in that case, you could argue that the C++ community was a little crusty. And so maybe, even though I thought Strustrup was, well, yeah, except that I don't, see, the thing is I don't, no, wow, I think you've just described a research topic. Yeah. I'm just going to skip that question, yes.
If you say there are sharp corners between OO and functional, I mean, pretty much you just said that Scala has a lot of problems because they're trying to mix this OO and functional, right?
Yeah.
So can you talk a little bit about what to do with sharp corners?
Yeah, okay. So I talked about the sharp corners between OO and functional.
Because Scala is OO.
Well, yeah, exactly. Well, no, that was the point that was brought up at the conference. Is that it was more of a just like it was okay not to understand monads, it was okay to see these sharp corners. I think the thing is we were going in I was going in thinking, oh, Martin has made this kind of seamless language, and every time that I would see one of these kind of sharp corner difficulty things, I was assuming that it was some misunderstanding on my part. And what whoever it was who pointed this out made me realize, oh, it's not always me. It's not always my it's not always my misunderstanding. There are times when you simply don't want to take objects and try and use them in functional ways. But examples, I think you said, what are examples of that?
I'm just saying that if you are here and talk about Scala, right, and you're saying there is a problem there, I think you should talk a little bit what are those sharp corners, because I think that's an interesting area for.
Yes, you're right. You're right. That is a completely legitimate thing to ask for. Why? Do you have a observation?
Well, is it in the real world? Do you find more people jumping into this, not respecting like immutability rules when they try to apply what they know about Java and Scala, or?
That actually sounds like a good example. Yeah, I mean, because you're creating objects that aren't immutable and trying to pass them through functional things which are expecting immutability. That's a good example. That's the kind of thing that I would probably have to think about longer to prepare a good, I mean, I think that could be a whole presentation. I agree that.
Because in my opinion, the functional stuff is much better organized than the whole stuff. Like you were talking about monads before, for
Yep.
example, like a famous functional person said a monad is an end-of-functor in a category theory, right? So.
Say that again. A monad is what? Maybe he's got it.
You don't need to talk about grandmothers and bus stops and stuff like that. Like a monad is an end-of-functor in the category theory, right?
Okay.
So which is something pretty precisely defined, defined and clear, right? So when you try to map that onto the OO, which is kind of rather fuzzy from that point of view, I think that's where it comes to problem. So Scala trying to map all of that functional stuff onto Java in particular, that's what it struggles with, right? So in my opinion, that's the tall order Scala has to fit.
Mm-hmm.
To fill.
Oh, it is a tall
So
order,
I'm
I
just
agree.
curious, what's your experience with that from what you're developing so far? Like, where do you see some of the people are struggling with that?
I don't know. I think that's something that, I mean, I'm kind of wondering if Scala 3 might try and address some of those things more. My man Bill might be a better, he'd say, because keep in mind that the book that Diane and I wrote was an introductory book that only went so far, whereas he wrote this really thick.
Yeah, Martin Modersky doesn't really like the Haskell way of doing things, and he is trying to actually define something in between that blends OO and functional, which is different. He really made the for expression so you could you can use it to do monadic things, but without knowing the word monad. And I think that's about as far as he thinks. That's what the Scala is designed to do, is pretty much that. So all these things that they do at Scala Z are not in the language or in the library because he doesn't really want to go that direction. So people coming from Haskell who really like that, they'll really be attracted to Scala Z because it does sort of put a layer on top of what Scala's type system is expressive enough to do all that kind of stuff, but the syntax is kind of clunky because it wasn't really designed to, that wasn't really the intent. But if you really want to do that kind of programming on the JVM, this is really the best way to do it today.
Right, so the equivalent would be like, pretty much like Bruce was saying, is like explaining advanced math stuff by using the grandmas and bus stops, right? So it just doesn't work, right?
Yes.
Question about developers' productivity in Scala in comparison to Java. You claimed a few times that in Scala you're more productive than in Java. But productivity means contains from three sides. First is development creation, supporting, and runtime. So where, at what exact stage developer got productivity? Because we also stress that Scala is hard to support language. You write one style, another developer writes a different style, and you don't understand each other. It's very well-known fact that Scala developers don't understand each other. That's why they're so mean, because If somebody writes the code, it could be that nobody could understand it because it's so short and have its own DSL language behind it. So you always need to relearn the language from scratch. You need to. So where is productivity?
Okay, yeah, you know, that's an interesting, okay, let me see if I can rephrase. You said productivity comes from the creation of the code, the maintenance of the code, and then the runtime performance? Okay, right, and then you made basically a blog post of all the issues. I think what you just said was a good comment. I mean, I agree. Those are all really good observations, and I don't know that I can.
For example, in Java, we have a special library that makes our code readable for the team. It's named the check style.
Mm-hmm.
So you can read the code very easily and quickly, as quick as English text.
Right.
So in Scala, it's also possible. It's different. It's definitely good from functional perspective because your mind is changing. Good for parallelism, but still you suffer from the language become not the language become problem becomes less readable, and it means that as soon as you created it, you know it's for sure. But in half of the year, you return to this code, and you say, what is it?
Yep.
And
you
nobody can support it. So it's
the Perl phenomenon.
Yeah, exactly.
Right. Yeah.
Just Scala is just a kind of Perl.
Yep. No, I think these are all those are all excellent observations. Yes, John.
Can you talk about your process of thinking about someone who had never programmed before and what they needed to learn first and why?
Yeah. Okay, so the question is, what was my process of dealing with somebody who'd never programmed before and how to bring them in? We, well, I guess I've had some experience teaching, but it's usually been people who are already programmers. So I think we had to go back and think, well, you know, what are our experiences? Well, Diane had 2 small children, precocious, but young, and kind of interacting with non-programmer types, kind of seeing the sort of problems that they have. The one thing that I mentioned, which was like give them small perks as they go on, give them a sense of accomplishment. I took a writing workshop, it was just like a half-day thing recently, and one of the things that the guy did was gave everybody little writing exercises, and then people would read what they had written, and then what other people in the room could do is come up with something to say that they liked about the writing. In other words, it wasn't a critique. It was really, the value of encouragement, I think, is really important to keep people moving forward. Because I guess the thing that I've seen most is when people can't understand something, they get stuck, and then they tend to want to give up the whole thing. You know, it's like, oh, this is too hard, I'm too stupid. And so our biggest focus was on that and ordering. So we wanted to give people something where, okay, you know, do something simple that you already know about, you know, arithmetic or whatever, and now do some exercises with that. Now we'll move forward. And each of the pages is, I mean, each of the chapters are only, you know, 2, 3, 4 pages long, so they would get that sense of accomplishment. And then we also decided to just work with a subset of the language. Originally, we were thinking that we would just focus on the object-oriented aspects of Scala, but then it just became really hard to keep the functional stuff out, and it also became really kind of fascinating to put that in. But I think we were able to, we had to choose the things that were what we thought were accessible. But a lot of it was just, you know, we think this is reasonable, we think this is too hard. The very last chapter, I couldn't resist putting in something about type classes because we had enough tools to be able to show it. It was the very last chapter, so that if people didn't understand it, it wouldn't prevent them from moving forward. But I felt like it was so cool and something that I had struggled with other languages, and it came out so cleanly that I had to put it in. So that was probably my one concession to something that might be a little too complex, but in the end, maybe not. So, yes?
In your experience, do you find that advanced programming languages like Scala, and by any advanced, I mean newer, do they make architectural patterns, like as described in the Gang of Four book, obsolete?
Well, I thought, yeah, so the question is, do advanced programming languages make architectural design patterns like those in the Gang of Four obsolete? I feel like there was somebody who observed that a design pattern expresses or indicates a language failing. And that really resonated with me, because the Gang of Four was really designed around C++ predominantly. And so when you move to other languages, there's a lot of things that you go, wow, we don't really need these design patterns. Some of these design patterns just don't really fit with some of these languages. You realize, oh, that's a pretty good indicator that kind of thing happens. So, yeah. Let me.
You made the point that it's maybe less productive to argue about languages these days.
Arguing about them, yeah.
Yeah, because people can just sort of try them, do the experiment, and I agree, but I wonder why now and not before. Why is it easier now for people to do that?
I think it's cultural. I think it's a cultural change, whereas before it just seemed like it was such a big deal to learn a language, and you invested in it. It was like a spoken language, and it required so much effort. But then people started saying, "Oh yeah, just to keep on top of things, you should learn a new language every year or something." Who was Dave and Andy Hunt were talking like that. And I think it's just become a kind of thing. Well, it's like, yeah, we learn tools, we learn languages, we learn frameworks and libraries and things. Language has kind of demoted from being this big important thing to just one of our set of tools. So, yes?
Based on your experience of designing languages, you meeting all these luminaries who are designing languages, your travels, could you give us your thoughts on two things? One, what is the state of language design currently? And then two, in the next 3 to 5 years, where are languages going? Where will we be?
Okay, so what's the state of language design, and where are we going to be in 3 to 5 years with languages? Wow. That's another whole presentation. I don't even know if I'm qualified to talk about that. Language design. I don't know. It seems like it's getting more sophisticated, and I think it's just a matter of people, like, for example, being able to build on top of a virtual machine gives tremendous power. So we're starting to see people be perhaps more experimental and try out things, and we're seeing the resurgence of things like Clojure and variation of Lisp, which is apparently supposed to have a lot of other benefits that I haven't looked into yet. And some of these other languages like Rust. It seems like it's gotten easier to develop reasonable languages in. Maybe it's just because of our body of knowledge or experience or something like that. Where do I see us in 3 to 5 years? It seems like things are going faster. So we're starting to see like the uptake of Go, and there's a lot of interest in Rust, and there's a number of other languages which we're starting to see being people are starting to use more quickly. And so I think perhaps there's going to be kind of more of an acceleration along those lines, whereas way back when, it was you just felt like, yeah, you had to choose your language and stick with it maybe throughout your whole career. So, yeah. Yes?
Maybe slightly related, are those language developments more philosophical or actually utilitarian?
Well, maybe in the case of Scala, there is a certain philosophical bent to it because of his emphasis on types and his looking at, let's take the object-oriented and functional paradigms and put them together and see what happens. Whereas when you look at, well, for example, Rust seems like it's really practical. They're saying we only want to include features that we've seen successfully used in other languages, and we're trying to build a complex result with this language, and so it needs to be practical. And Go also, I think, has that practicality into it. So probably both those things.
Are those like, I mean, in R, you would say it's for data analysts. Are some of the languages are geared toward a particular type of problems or a particular type of situation, or are those problems evolving, or how does that influence language?
Yeah, I mean, that's an interesting, R is an interesting example because it's like tuned to a particular thing. You could probably argue that Perl was originally designed for a similar focus. Special purpose languages, and of course we've seen them for like scientific stuff. What's that? Somebody help me out here. What's the MATLAB? MATLAB has, that's kind of almost a language, and then there's an open source version of that, and there's, maybe what we're seeing is kind of a smearing, a kind of blending, because sometimes you see languages, Python gets adapted a lot to solve special purpose problems, and then sometimes you see languages created specifically to solve those kinds of problems. It's like one big ongoing experiment, and we try stuff and we see what works, which is, I think, the way we should be, rather than saying, oh, I've chosen this language and I never want to see it change.
It's a market mechanism or something.
Yeah, I think you look at it that way. So, yes?
Bruce, I have a comment on the community, right? So you say you encounter some info. I'm sorry to hear that. So I actually started learning Scala using IRC, and the best way to learn it is just ask questions on IRC. And 5 years ago, I think mostly folks are really friendly. However, what happened in the last few years, so we have now kind of functional tribe, which I call crypto Haskellers, which are kind of, it's hard to get the job using Haskell, but you actually can get the job using Scala, and a lot of them, by the way. So, but anyone needs a job using Scala, just ask me. I can put you in touch with other people who need developers. I think what happened is there is always this advanced tribe, and recently we came out with a similar nomenclature like we used, but we have Scala tribes. We have newbie tribes, which are Java converts. We have actually middle tribes, which maybe like Ruby people actually have more advanced than Java people in terms of FP. And then we have this Haskell wing. So we have fragmentation. The Haskell people are kind of on the outward trajectory, so they're going to Idris dependent types. They want something really, really functional, or Agda and things like that. So my question to you, so like, how do we keep this community together? How do we manage the extremes and like stick to the middle? How do we kind of make the whole thing harmonious? Do you have any ideas based on what you've seen?
Well, I guess the most success that I can't repeat that question. It's too long. The most success I've seen has usually had like a community leader person somehow, and like somebody like Dick Wall, who's just the nicest guy, and he wants everybody to be nice to each other, and he's a good portion. He's a good part of the Scala community. So somebody like that to kind of try and lead the niceness faction. And in Python, this happened, well, right from the top, because Guido always wanted everybody to be nice to each other. And so that's one way. But my own research in the whole reinventing business world has been away from the idea of leadership and more into flat, self-organized organizations. And so I'm thinking, well, is there a way to, I guess you could say the way Netflix structures its culture is that they're very careful about who comes into the fold. And maybe that's, in a sense, what Guido did with the Python community, because he had the core Python team. It wasn't just him, it was the team. And I've hung out with those guys, and they're all just super nice, the nicest people you'd ever want to hang out with. And so they, in turn, are a huge influence on the rest of the community. So it isn't just Guido by himself. So perhaps what you need is a core group. And that's the group that you're able to, in a sense, select for culture. So I don't know, maybe that's a possible approach.
Yeah, back on the multiplicity of the languages, I think it's great to also work because we learn things from, I don't know, JavaScript that we'll use in another language. And what are your advice on anti-pattern of development to be more fluent in changing language and adapting?
You mean changing from completely other languages to Scala?
Ready to make to build a culture in a company, or to be more able to change language. I think one of them is to make, I don't know, tests which are driven by data. So that's easy to say, oh yeah, here is the data, and we can do this test in Java or in Scala, and it's more or less ready. You don't have to rewrite. Okay, what are the patterns that you encourage to be ready to swap to the language to another?
Mm-hmm. So are you thinking, well, so the question is, what sort of patterns or approaches are useful to try and change from one language, not necessarily Java, right? Okay, any other language to Scala, I assume you're talking about, or just any? Mm-hmm. Yeah, I think, I always feel like you've got to look at motivation and go from there. In other words, and I think you have to evaluate. One of the problems that I've found with a lot of consulting companies or consultants is the kind of carpet bombing approach, drive-by. They come in and they say, well, okay, everything you're doing is wrong, and stop doing that and do it my way. And that has no effect at all. And so what you really need to do, as soon as they're gone, you're going, wow, what a fun guy that was. But I think what you really have to do is understand the group that you're talking about and where they are and what they're ready to do. And so, you look at them and you say, well, are they even possible to motivate to move to another language, or are they just going to resist you the whole way? And you have to kind of go in and get a feel for that and understand that, because if they're not able to do that, then you should spend your time doing something else. I mean, one of the things that they talked about in the Pragmatic Programmer was that if you're not doing testing and version control and automation, then all the rest of the stuff that you might want to do is kind of meaningless. You have to start with those. And when you're working with a group that maybe isn't doing any of those, you want to introduce those things one at a time. So it might be that I'd say when coming from Java, Scala is an easier transition, because you can say, well, maybe we'll bring in something that was written in Scala that does something amazing that you can call from Java, and kind of begin to motivate that way. People start getting curious, wow, this thing is amazing, and it seems like it would have taken a huge amount of effort to write it in Java. I wonder what's underneath the covers there. But I think the motivation is going to be different depending on the company, the group, the culture that you're working with. And so I don't know that we're going to be able to come up with anything universal. We tried with our book, we tried to make one aspect of that transition as easy as we could imagine. So people might be able to, who are thinking about it, might be able to go through and sample it, and by the time they reach the end, they discover, well, yes, I'd like to know more, or no, this language really isn't for me. So, anything else? Yes?
Can you talk more about the mechanics of switching languages? I'm thinking sort of Java and Scala is a special case where they're interoperable and you can kind of blend them seamlessly, but if you have a legacy code base that's written in one language, you either have to rewrite it or you need integration points, which can change the architecture. How do you go about adding new languages in a clean way?
Okay, so what are the what are the issues around changing languages, especially when you're sticking with, or you have, yeah, see, for example, this one consulting client I had, they had a lot of code written in Java. Problem was that it also had a lot of coding issues that it probably would have taken longer to go in and root those out than it would be to, at least for some of it, to just write clean code, in their case, clean code in Python. I guess I kind of have to fall back on the same answer that I just gave. Well, it's a joke, you know, whenever you ask a consultant a question, the answer is, it depends. And unfortunately, well, and I think that's the right answer for these situations, because you really have to, it would be lovely. I know we're computer programmers and we like to think of things in terms of absolutes and ones and zeros and everything is deterministic, but it really ends up being, you have to look at the group that you're working with and the problems that you're working with, and sometimes the answer is no. Sometimes the answer is you shouldn't change because the cost and the struggle and the time and whatever involved just doesn't justify making that change. Or maybe the answer is, okay, we do the little experiment over here with a group of people, and they come back and report pluses and minuses, and possibly teach the others, draw the others in, rather than, I think it's much better to do that than to have outside sources teaching it, because then it's somebody within your community. There's a number of different approaches that you can use to this, but the ultimate answer is, well, it kind of depends on what your situation is. And you really do have to kind of look at these things and say, is this the right thing to do? And if it is, what rate do we move at? Do we try and jump all at once? Do we jump partially? Do we do some little projects in this while leaving the rest of it in our existing code base? All those things are possibilities.
So it makes sense, it depends on the case, but maybe can you talk more about that particular case as a case study? Like, was it a large Java code base that they wanted some Python?
It was pretty significant. That wasn't their initial thought. Initially, they wanted to like fix the Java code base. But there were some things that could be so quickly solved using a different language that basically I was just doing it as a proof of concept. And you know, here's how to solve this problem. Here's a proof. And then if you want to, you can take the algorithm and then go back and code it in Java. I wasn't trying to force them to move into this new language. I was simply saying, well, here's an easy way to think about the problem. We can do a prototype of it using this language where we can do it very rapidly. And then if you want to do it in Java, you can. But they decided that they liked the speed and the clarity of what we were able to do in Python, and eventually moved over to it. So yes, there's an example of, yeah, I couldn't have planned that. I wasn't even trying. I was simply trying to give whatever help I could. And they ended up deciding, well, you know, we're going to be more productive this way. So, yes?
Okay. Earlier in the presentation, you sort of raised the idea of sort of Scala falling into a pit, and then towards the end of sort of us getting Scala developers being sort of trapped in a box based on the development of the language. Is that sort of a purely hypothetical warning, or do you have specific notions of areas that maybe we're already getting stuck in that are going to be pain points?
I guess the biggest one that I can think of would be where we might be stuck already is just the variable ways of expressing things. You could have the same piece of code. You could understand this piece of code, you see this, and you have no idea what it says, and you have to go and unravel it. I would say that could be, that might be the biggest problem that we encounter, because people often, I mean, Perl used to have obfuscated coding contests to say how, and I mean, did we didn't somebody do this in Scala as well? Yeah, having obscure Scala.
There's obfuscated code contests for
Sure, for everything, right? Okay, so fine. But really, when you have such a wide variety of expressiveness and no culture behind it to say, yeah, this is the way we do things, then it seems like that could be one of the largest potential problems that I see off the top of my head. Yeah. So, yes.
So when you did this transition between Java and Python, did you consider Python so that you don't have to impact to?
Yeah, we did. We looked at that. Well, I think the reason that we didn't really look at it in much depth is that the intent wasn't to move from Java to Python. It was just to prototype in Python. And the thing just grew legs of its own. So the logical thing might have been to, if we had been thinking that that's where we were going, the logical thing would have been to look at Jython. Actually, I think at one point I put them in touch with Jim Baker, who was the maintainer at the time. But I don't know, for some reason they decided they didn't want to go that way. So, all right. Maybe one more question if there is one. Or, yes?
Yeah, so for me, when I use Java, it's actually okay because of IntelliJ. But if I didn't have IntelliJ, I would hate Java. So how important do you think tooling is to language adoption? And do you think that should be a bigger area of focus? To some extent, I almost see it as more important than the actual languages themselves. But.
Yeah, no, that's an excellent point, tooling and the tolerability of Java. But of course, you're talking about generating the code, not necessarily comprehending it. I mean, it still makes the nature of Java still makes comprehension a lot more difficult.
Sorry, but not actually just generating because of being able to jump between classes, pull up docs.
Well, good point. Yeah. Yeah, I was thinking of the actual code itself still has more words and stuff in it, and so your brain has to spend more time parsing it. But yes, the tooling in general, yeah, that seems really important. If you're asking how important it is for adoption, I don't know. It seems to be something that people are kind of insisting on now. They're going, where's the tooling? Or do you have a comment about that?
For compile speed, often moved away from using Scala for more or less one large reason, which was just a large Scala code base was really slow for our CI process, which is unfortunate.
Mm-hmm. And that drove you away from Scala?
It was one factor.
Okay. Okay. Yeah. So
there was a cultural rift between those who really liked Java and wanted to stay with it, and those who were advocating Scala. But it was ammunition against Scala that was difficult to.
And I do think build times. I mean, you have to keep in mind how long your attention span is, and if the build takes more than a certain number of seconds, which is like 3 or 4 or something, you drift off, and that makes a big difference. That's not something to be ignored, because it allows you to be much. You can go through many more cycles if the build time is quick. So, but of course that's different than editor tooling. But also important. It adds. I guess what you're really talking about is your experience of working with the language. And if you have the right tools, the debuggers, profilers, all that kind of stuff, and it's quite seamless, then your experience of working with the language is going to be a lot better. Yeah, I don't think we can argue with that, and regardless of the language. And people are demanding more and more of that. When they see a new language, they go, what is my experience going to be? They usually put it in terms of tooling, but ultimately what they're asking is, what is my experience going to be? That's why a lot of people get excited about a language like Go, where it seems like the cursor can't even reach the end of the next line before the compile is done. And that makes a difference in their experience. So, okay. Thanks everybody for coming, and I guess we'll be around for a few minutes. So if you want to talk informally, we can. Thank you.